Yeah, good morning all. Today we'll discuss about linear search technique. Okay, there are two searching techniques. One is linear search and another one is binary search. Okay, so where we use these searching techniques. That means you have a set of elements and you need to identify whether a particular element is present in that or not. Okay, so this is useful in real time where you have stored all the data of students or all the data of employees in an organization, and suddenly you want to find the data of particular student or particular employee. Okay, so in such case we can use one of the searching the techniques. Okay, so say for example a person by name Srinivas is present in an organization or not. Okay, or if I want to search a particular rule number student. Okay, so then I can search using one of the searching techniques. Okay, so because otherwise manually if you search you have to go through all the data of all the students class wise, which takes a lot of time. Okay, so if you write a program where data is available digitally, then within no time these searching techniques gives the result whether is present or not. Okay, so there we use, even in Google if you type something like Java or C compiler, then immediately it is giving all the links. Okay, so at the back end it is using one searching algorithm. There are other searching algorithms also, efficient searching algorithms. Then it is giving all the links. Okay, right, so we'll talk about this linear search in today's class. So linear search is a sequential search algorithm which uses a simple loop to step through an array. Initially we store the elements in an array. Assume the elements are stored in an array. Okay, so then starting from the first element onwards, okay, so we go on search for a particular element in the array. Okay, so we search in a sequential model. Okay, that means linearly we search. That's why the name linear search. Okay, so see here. So it compares each element with the value being searched for. Okay, so each element is compared with the value being searched for and stops when either the value is found or the end of the array is reached. Okay, so in these both cases, then your algorithm stops. The value being searched is not in the array. That means you compared all the elements and you reached the end of the array. Okay, so you can say the algorithm is unsuccessful and it will unsuccessfully search to the end of the array. So it goes up to the last element of the array. And when it reaches up to the last element of the array, and you can say that the algorithm is unsuccessful, or in other way the element is not found. Whatever you are searching for, it is not available in the list. Okay, so since the array elements are stored in linear order, okay, how the elements of array stored? They are stored in contiguous memory locations. Okay, so that is nothing but their order is linear, we can say. And searching the element in the linear order makes it easy and efficient. This is general technique we use in our daily routine. Linear search. So the search may be successful or unsuccessful sometimes. Okay, so that is if the required element is found, we can say the search is successful. Otherwise, it is unsuccessful. That means the required element is not found. then we can declare that it is unsuccessful. So what are the advantages of linear search? The linear search is very simple technique. Okay, so every common man uses this technique in their daily life. It is very easy to understand and implement. Okay, it is simple technique, first one. Then it does not require the data in the array to be stored in any particular order. Okay, so some techniques require the data to be stored in a particular order, but here in linear sets you can store the data in any order. Okay, so in sorting order or unsorted order, in whatever order the data is stored, then you can search for a particular element by using this linear search. That is the advantage of a linear search algorithm. So first one is, it is very simple algorithm, easy to understand and implement. And second one is, does not require data in any particular order. What are the disadvantages? The disadvantages are very poor efficiency. Why? Because it takes lots of comparisons to find a particular record in big files. For example, you have very huge files. Okay, you stored data in files and you are searching for a particular record, like you have stored some student data, no? That is called one record. Or employee details you have stored using structure. Okay, so that is called one record. Okay, now you are going to search for a particular record in that data. Okay, so then if we use linear search, okay, so it is very poor in efficiency, because it starts comparison from the first record onwards and goes to the last record, up to last record, and every time it compares with each record. If the record is not available, then it performs all records comparison. Okay, so that's why we say that it is very poor in efficiency. The performance algorithm scales linearly with the size of the input. Okay, that means your input size, as it is increasing, the performance of this algorithm decreases. Okay, that means it takes a lot of time for searching an element in the large data. Okay, so if your data is increasing, then the time for searching also increases. That is the meaning of this point. The performance of the algorithm scales linearly with the size of the input. Okay, so this is the disadvantage of a linear search algorithm. Linear search is slower than other searching algorithms. Okay, so compared to other algorithms, it is very slow. Okay, because it compares almost all elements. In worst case, it compares almost all elements in the list, which takes lot of time. That's why we say that it is very slow. Okay, so these are the disadvantage of linear search algorithm. Okay, so we'll take an example and we'll see how the linear search searches for a particular element. Just see, assume that I have stored some numbers in an array in this order. Okay, minus 23, 97, 18, some random numbers I have stored. 21, 5, minus 86, both positive and negative numbers, 64, 0, minus 37. Okay, so these are the numbers I have stored in the array. Okay, so now I am searching for minus 86. Okay, so I want to know whether minus 86 is present in the array or not. Okay, so I use linear search here to search for minus 86. Okay, so how linear search starts searching? It starts comparing starting from the first element onwards. Okay, so first it searches whether the first element is equal to minus 86. What is the first element here? Minus 23. Minus 23 is equal to minus 86? No. Okay, or we can say, is it the first element? Minus 86 is the first element. Then we can say unsuccessful. No, it is not minus 86. First element is minus 86. No, it is minus 23. No, so that's why we can say that it is unsuccessful. First element is not the one. Okay, so then it goes to the second element. Then searches. Second element is minus 86. Compares. Okay, so what is second element? 96 is equal to minus 86. No, false. Okay, so then unsuccessful we can say here. This attempt also unsuccessful. Then it goes to the next element. Is the third element equal to minus 86? What is third element here? 18. 18 is equal to minus 86? No. So then here also it is unsuccessful. Then it goes to the next element. 21. 21. Okay, so then it compares whether 21 equal to minus 86? No. Okay, so false. So that's why we can say this attempt is also unsuccessful. Okay, so then it goes to the next element. Like this, it goes on comparing element by element in linear order. That means one after the other until it identifies the element. Otherwise, it goes on searching until end of the array is reached here. Okay, so then it goes to the next element. 5 is equal to minus 86. No. So then this attempt is also unsuccessful. Then it goes to the next element. Minus 86 is equal to minus 86. Yes. Then it declares that element is found. Okay. So if it is found, then it returns the index of this element. What is the index of this element? Say this is 0, 1, 2, 3, 4, and 5. Okay. So then it returns this index 5 it returns. That means we can say that the element minus 86 is found at a location 5. Okay. So otherwise, is it, if this is also not, then it goes to the next element. For example, you are searching for some 100. Minus 86 equal to 100. No. Then it goes to next 64 equal to 100. No. Then it goes to next element. 0 equal to 100. No. Then it goes to next element. Minus 37 equal to 100. No. Okay. So once it reaches end of the array, that means last element also it compared, and if it is unsuccessful, then we can say that the element is not found. Okay, if it is found, then it returns, say for example minus 86, then the index of this is 5, so 5 it returns. Okay, so how to implement this, whether element is found or not found? In programming, generally what we do is, if element is found, then its index 5 we return. If element is not found, generally we return minus 1. Okay, so when minus 1 is returned from this, we can say that the element is not found. Okay, if you implement this as a separate function. Clear? Okay, right. So the same task, whatever we performed now, okay, so we have to implement using a C program. Okay, so your program also should perform the same type of comparisons. Okay, so how we can implement this technique using a C program, we'll see now. Okay, right? So we'll write a program for this. Let me open the code blocks. Where is the code blocks? Yes, here. Yeah. So I'm creating an empty file here. Okay, so we'll write program for that. Now I'm writing the comment here. Program for linear search. Linear search. Okay, so then what next? Include the header file. So include include stdio.h, close angle brace. Include the header file. Okay, so then write the main function here, then begin the main. Okay, so first declare the variables. What are the variables required here? First we need to store the numbers in an array. Okay, so you declare an array here, a of size some 50 you declare. Okay, then similarly you are going to use 50 elements. So you should ask the user to enter number of elements that you catch in n. So to read elements into the array, we require a loop. For that, a loop control variable we require. Okay, so I am declaring here. Okay, right. So initially these are the variables we require. First, we ask the user to enter how many elements he wants to store in the array. Okay, so say enter how many elements the array. Something like question we are asking, so you can use question mark also. Now he entered some 5 numbers, 10 numbers. You read that value using scanf function. Say percentage d comma and catch that value in a variable called n. Okay, so n elements, we can say that n elements he wants to store in the array. Okay, so then he should enter n elements into the array, no? So give a message to the user. Say printf, ask the user to enter the same number of elements. Okay, so here whatever number he entered, that should be printed here. Okay, so where is it stored? It is stored in a n. Okay, so n value you need to print here, so that's why you should use format specifier here. So enter percentage d elements, or you can say numbers. Okay, so here also we can use the word numbers instead of elements. Say enter how many numbers you want to store in array. So enter percentage d numbers, then say new line comma, where from this percentage it should print the value from variable here. Okay, so he enters some 5 numbers, then read them and store into the array a. Okay, so to read elements into the array, we require a loop. I'm using a for loop here for I is equals to 0. I starting from 0 because I index array index begins from 0. Okay, so then I less than n, n elements I have to read. Okay, so then increment I value I plus plus. Okay, so one by one you have to read. So how to read? Using the scanf function, because the numbers entered through keyboard. Percentage d comma, where should I store now? Address of a of I in each index, in each location of the array a I have to store. So that's why I have to use address of a of I. Okay, so this loop reads elements of the array. Okay, so that means now your array contains elements. Okay, so now again you ask the user to enter the element to be searched, because he has to tell us which element we need to search in the program. Okay, so then ask the user number to be searched. Okay, so and he enters some number. Okay, so that you catch in some variable. Okay, so for this we need to declare a variable here. Okay, so what we call that variable, you can call it as element or num also you can declare. Okay, so we use the variable called as a num here. Okay, so then catch that value in the variable num. Okay, so whatever number he wants to set, that we are storing in the variable called as a num. Okay, so first we have stored some elements in the array, then we are asking the user to enter the number to be searched, because which number we need to search, user must specify, no? Okay, so then only your algorithm can search that number. Okay, right. Now, once he enters the number to be searched, now you can go through the array starting from first element onwards. Okay, so now this is the code for linear search. Okay, so code for a linear search. This is the code for linear search here. Okay, so starting from first element onwards, you have to go on search. That means you have to use a for loop here. So for I is equals to 0, then I less than n. Go to up to the last element you need to go here. Okay, so I plus plus, increment I value here. Okay. Then you can go on searching from first element onwards. I is equal to 0. Okay, so now you compare whether the first element is equal to the number to be searched. How can we write a statement here? If, to compare, we use if statement. If, okay, so a of 0, first element, is equals to num. Num is the number to be searched. Okay, so if a of I is equals to num, if yes, that means we identified the element. Okay, so directly we can print a message here. We can print a message here. Okay, say printf. We can print the message like the element or the number. Okay, so the number is found at location. Okay, so where is it in location is nothing but I is the index or location of that element is found at okay, so percentage d index, we can say the element is found at a percentage d index or percentage d location, you can say. Okay, so found at so and so location, some message you can print here, comma, where is the index here? I is the index of the element. Okay, so once you identify the element, then immediately you come out. Okay, so for that, to come out from the program, we have exit function. Now you can say exit 0. Immediately you come out from the program. So otherwise what happens? It goes to the next element. So this is not required because this is the only statement of the for loop. So this is not required here. Okay, so if a of I is equals to num, then what we are doing, we identified the element, then we are printing the number is found at so and so location, then we are coming out from the program. Otherwise what happens? Then it goes to increment of a I value, I plus plus, it goes to I value becomes 1, then it searches. Okay, a of 1 is equal to num. So like this it goes on comparing until either it identifies the element or it reaches end of the array. Okay, right? So if it reaches end of the array and it comes out from the loop, okay, so that means you can say that the element is not found. Okay, so once you come out from the loop, directly you can print that the element or the number is not found. That is how you can print here. Okay, so that means if you are coming out from the loop means you are unsuccessful. Okay, so that means there is no such a element, and finally you can print here return 0. Return 0, then end of your program reaches, your program closes here. Okay, so this is the code for a linear search. Either you print the number is found at so and so location, or if you are coming out from this loop, then control comes to this printf statement. Okay, so then when it reaches this printf, you can say unsuccessful, the number is not found. Okay, so let me save the program. Now what we can say, this is linear, no? So linear search dot c I'm saving here. Okay, now this is the program. Just try to see here. Have declared an array, number of elements in the array, and a loop control variable and number to be searched, num. First, I'm asking the user to enter how many numbers he wants to store in the array. Then I'm asking the user to enter those many numbers into the array. I'm storing those numbers in the array by using this for loop and scanf function. Okay. So then I'm also asking the user to enter the number to be searched, because he has to specify which number to be searched in the array. Okay, so he enters some number that I am catching in a variable called as num. Num is the number to be searched. Now using linear search techniques, starting from the first element onwards, I am going through the array until I reach last element. Okay, so what I am doing here, I am going on comparing each element with a num here. Okay, so as soon as I found an element or the element to be searched, then I am printing here the number is found at so and so location. Then I am coming out from the program. Okay, otherwise it goes to the next element and compares. Like this, it goes to up to end of the array and comes out from this loop. Okay, so once the control comes out from this loop, it comes to this printf statement. The meaning is it is unsuccessful. So just you can print here, even you can write a message like unsuccessful, the number is not found. Such kind of message you can print here. Okay, right, now we'll execute this program. So I have saved this program. Now I'm building the program, compiling the program. Okay, so there is one error here. What is this error? See here, I have used two square brackets here. Okay, so this is the error. Right, save the program again you compile the program. Okay, so this time there are no errors in the program. Okay, so then run the program. Now see, enter how many numbers in the array. Okay, so if you want the same numerical example to use, I can use, see how many here, 1 2 3 4 5 6 7 8 9 elements are there. Okay, so I can enter 9 here, enter 9 numbers. Okay, so just I can enter the same 9 numbers here. Just see here, minus 23. You can use positive and negative numbers, no problem. Okay, so 97, 18, 21, 5. Okay, minus 86, 64. Okay, 0, then minus 37. Then it is asking the user enter the number to be searched. Okay, so which number to be searched? As in numerical example, minus 86 is the number to be searched. Okay, so then the number is found at location 5. Okay, so it is identified at a location 5. You can see here in this array, see 0 1 2 3 4 5. At location 5 the number is found. Okay, so that means if you go to location 5, there is an element called minus 86. That is the meaning. Clear? Okay, so once again we enter the same numbers, but this time element to be searched is different, we'll enter. Okay, so then in such case what it returns, we'll see here. So here I use a new line. Here also we can use a separate new line. Okay, right. So now we'll see if we enter a number which is not present. Okay, so this time I take some random data here. Enter how many numbers? Some 5 numbers I am taking. Enter 5 numbers. Okay, so 55, 22, 88, 11, and 66. Some numbers I am entering randomly. Enter the number to be searched. 100 I enter. Okay, now you can see unsuccessful. The number is not found. The number is not found. Okay, so how it is identifying? How it is identifying? Okay, so I'll show you step by step method with the help of an example. So let me copy this here. Now this is our program. Okay, so what I do is I take 5 numbers. Okay, so I draw the same array diagram here. Then I'll tell you how it is identifying those numbers. Okay, so assume this is my array. Only array with the 5 numbers I am drawing here. Okay, so this is first element, second element, third element, fourth element, say fifth, sixth. Okay, so 6 numbers I'll take randomly. Okay, so something like 66. Okay, so 22 here, 88, 44, 11. Okay, so 55. Assume these are the numbers stored in array 0, 1, 2, 3, 4, 5. Okay, so 6 numbers I have stored in array and the name of array is A here. Assume this is my array A. Okay, so first enter how many numbers to be stored. Okay, so here this is n value. Assume this is n value. So how many numbers? 6 numbers. Enter numbers means you enter some numbers and assume that the numbers are stored in the array in this way. Okay, clear? Right? So then it displays this enter the number to be searched. Okay, so assume this is the memory for num. Enter the number to be searched. This time I entered the number to be searched as 100. Okay, so I am catching that in a num. Num contains 100. Now 100 I need to search here. Okay, right. So here now this is the code for a linear search. Okay, so first I value we will trace here. This is I value here. Okay, so first I will become 0. Okay, so then it compares 0 less than 6. Yes, then it comes here. So A of 0. A of 0 is what? 66. 66 is equal to num. What is there in num? 66 is equal to 100. No, false. So then this code is not executed here. Okay, so this code is not executed here. Okay, so then immediately it goes to this I plus plus here. It comes to this I plus plus. Okay, so I value becomes now 1 here. So what I do is I write I values like this. Okay, so I value now becomes a 1 here. Okay, so 1 less than 6. Yes, then again it compares A of 1. What is there in A of 1? 22. 22 is equal to 100. No. Okay, so then again this is not executed. Then it goes to I plus plus. So this time I value becomes 2 here. Okay, so then compares again 2 less than 6. Yes, true. So then it comes to next statement. A of 2. If A of 2 is equal to num, what is A of 2? 88. 88 is equal to 100. No, false. So then again goes to I plus plus. Okay, so I value becomes 3 here. 3 less than 6. 3 less than 6. Yes, true. So then again comes to this if statement. A of 3 is equal to num. What is there in A of 3? 44. 44 is equal to 100? No. So again it goes to I plus plus. So I value becomes now 4. So compare again. 4 less than 6, false. Sorry, 4 less than 6, true. Okay. So again goes to this if statement. If a of 4 is equal to num, what is there in a of 4? 11. 11 is equal to 100? No, false. So again goes to I plus plus. So I value becomes now 5. Again goes to condition part here. Okay, so 5 less than 6, yes, true. So again compare here. A of 5, what is A of 5? 55. So 55 is equal to 100? No, false. Then again it goes to increment part, I plus plus, I becomes 6. Okay, now see here, now it goes to this condition part. 6 less than 6, false. Then the control comes out from the loop, and once it comes out from the loop, the control directly jumps to this if statement here. Okay, so that means the control is coming out from the loop, means it has searched every element of the array and reached the end of the array. Okay, so that means there is no such a element to be searched here. So we can say that unsuccessful, the number is not found. Then this message will be displayed on the screen. If some number is identified here, what is happening? 88, for example. Okay, so element to be searched is 88, for example. Now what happens? First it starts from first element onwards. A of 0, 66 is equal to 88? No. Okay. So then it goes to next element. Okay. So then searches A of 1 here. Okay. So 22 is equal to 100? No. It goes to next element 88. 88 is equal to 88? Yes. True. Okay. So then it prints the number is found at percentage d location comma I. What is I value here? 2. Okay. So then you will get this message displayed on the screen. Number is found at a location 2. Then exit 0. Immediately exit 0. Exit 0. When this is executed, your program comes out exits, and the control comes out from this program. So that's why it won't go to this statement. Okay, from here itself, your program ends. Okay, so that's why this is not printed here. So you can see the number is found at location 2. Clear? Okay, so this is how the linear search algorithm works here. Okay, so statement, each element by element, it compares linearly. It is comparing linearly without missing any element. This is called linearly, means one after the other. That's why the name linear searcher is used here. So this is linear search algorithm and it's a program. Okay. You can simply modify this program. See, the number is found at a location, so and so location you want, or instead of saying at 5 location 5 you can say. Okay, so at location 5 you can say. Here you can use percentage d. Now it prints in this way. The number is found at location 5. The number is found at location 3. That's how you get the message there. Okay, so this message or the output to be displayed. Okay, so it is up to us how you want the message to be displayed, and you can accordingly write the statement in this double quotes of printf statement. Okay, right.